So for demo number 1, I have my daughter in a black trash bag, and I'm going to turn the vacuum cleaner on, and she has a vacuum hose in there with her.
Oh my God.
Demo number 2. Go ahead. Okay, so did you catch that? No? Need to see it again? All right. So what is making the liquid go up the straw? Think about it. Demonstration number 3. So I put a little bit of water in the bottom of this aluminum can, and I am putting it over fire. If I was in the classroom, I would be doing this over a Bunsen burner. And we are waiting until we see water vapor coming out the top of the can. Once I see water vapor coming out of the top of the can, I'll give it a little bit more time to heat up, and then I'm going to put the mouth of the can in a bucket of water that I have here, and we're going to see what happens. So 1, 2, 3. Okay, so take a look at what happened to the can, and think about the science behind it and what that explanation would be as to why that happened. Hint, I did not squeeze the can. So go ahead and pause the video for a few seconds and think about what the answer would be to each one of those. Why did the bag suck in? Why did the liquid go up the straw? And why did the can get crushed? How did that happen? Hint, the answer is basically the same for all 3. Go ahead and pause the video now. Think about it. Okay, so the answer to all 3 is air pressure. When my daughter was in the bag, and it seems like the vacuum is sucking all the air out, but really what it's doing is when all the air comes out of the bag, then the outside air pressure outside of the bag, the air pressure that's normally around us, ends up being greater than the pressure inside the bag because you've sucked all that air out and created kind of like a vacuum. Then the next one, for the liquid one, for the going up the straw. So what happens is that right now the air pressure inside the straw and inside the cup is the same. As soon as you suck the air out of the straw, then the air pressure pushing down on the liquid becomes greater than the air pressure inside the straw, and the air pressure pushes the liquid up the straw. I know it's kind of a weird way of thinking about it, but that's what's happening. And then with the can, where's the can at? So then with the can, what happens with the can is that you have a bunch of liquid water that then turns into a gas, and that gas is taking up the entire inside of the can and coming out the top. And when the can gets turned upside down into the cool water, then all of the gas molecules that were water, they end up cooling really, really fast and turning back into a liquid. That's called condensation. And so all that liquid water then is not taking up as much room in the can as that gas water. And so the outside air pressure ends up being greater than the inside of the can. So it's the outside air pressure squishing the can, not me squeezing it with the tongs. So if you bring in a can this week or next week, I will let you do that example in class with a Bunsen burner and a tub of water. So again, with the bag, the outside air pressure became greater than the inside air pressure because you sucked all the air out, and so the bag was pushed in. With the drink, the air pressure pushing down on the liquid was greater than the air pressure in the straw when you sucked on the straw and took all the air out, so that's why the liquid went up the straw. And then with the can, the outside air pressure ended up being greater than the inside air pressure, and that's why the outside air pressure squished the can from the outside.